Greetings, fellow cloud engineers. In this episode, we're diving deep into the cutting-edge realms of the TimesFM forecasting model. Developed by the minds at Google Research, this open-source, pre-trained model is a game-changer for time series forecasting. Interested? You can check out their scholarly paper and the complete source code. Plus, Hugging Face guarantees an extra layer of convenience by hosting the model checkpoints. Whether you're an enthusiast or a professional, it's time to turbocharge your Python time series skills. We're going to take you on a thrilling expedition of how to utilize this TimesFM model, leveraging vital components. For this demo, you can follow along in any IDE or notebook environment of your choice. Our pick here will be a Vertex AI Workbench notebook, a managed Jupyter instance running on Google Cloud. To get started, fire up the Compute Engine API and the recommended Vertex AI APIs in the Google Cloud Console. One exciting fact, this model is GPU friendly. So while enjoying a beautiful synergy between code and Vertex AI, you also harness the power of GPUs. This is important as the model is usually best run with the GPU. We'll show you exactly how to add some GPU magic to your notebook. Once those APIs are running smooth as silk, bounce over to the Vertex AI Workbench service to conjure a new Jupyter instance. We'll select a T4 GPU and an N1 standard machine that's budget-friendly at just about 50 cents per hour. Since this is a managed Jupyter service, there's no need to worry about setting up GPU libraries or other low-level details. Just make sure to choose a GPU-equipped machine type. With a single click on the Open Jupyter Lab button, you can pierce right into the heart of the environment and kickstart model exploration. This notebook comes pre-installed with essentials like CUDA libraries, saving you some precious time and effort. The very first task is configuring our environment. It's dependency time. A quick round of pip installs will get the required components on board, including Hugging Face Hub, the forecasting utilities, PyTorch, and JAX libraries. To keep things clean and quiet, we'll join some of these installs into a single command and use the quiet flag to tame the verbose output. Step 1 complete. Wait, something's missing. Oh, it's the TimesFM package itself. Although not listed on PyPy, the developers advise installing it directly from the GitHub repository. To verify a successful installation, we'll put it to the test by importing the package. Voila, it's a pass. Code is ready, environment's prepped, and now on to setting up our model. The TimesFM model requires specifying a context and a horizon. The context is how far back the model will focus on data for making forecasts, and the horizon is how far we want to forecast into the future. Note that these values need to be multiples of the input patch length. Let's set the horizon to 96 and the context to 192. This would give us about 3 months for the horizon and 6 months for the context, assuming our data has a daily frequency. The backend parameter is where we want to specify the type of hardware to use. We'll choose the GPU option to take advantage of our T4 GPU. As usual with models like these, it can be tricky to ensure all versions, such as CUDA libraries, are correct, but we'll give it a shot. The other hardware options are CPU or TPU. If we encounter issues with the GPU backend, we can revert to the CPU option, but let's go ahead and try the GPU first. While the model is loading, let's check our GPU setup. It looks like we've got significant GPU memory usage, which is a good sign. We're using about 12 gigabytes of the available 16 gigabytes. We've got a clean environment and successful GPU usage, a great start. Note that the model parameters we're setting are based on the checkpoint loaded from Hugging Face. We don't want to change these. You can see more details about this checkpoint and the associated model card by clicking on the Hugging Face link. Let's continue with some inference work. Say we want to do some sales forecasting. For the data setup, we'll use Pandas, Numpy, and the datetime module. We can model the sales data as a linear trend, but we'll introduce some normally distributed noise into the data for a more realistic scenario. We'll compile this into a Pandas data frame. Then we'll create a forecast data frame using the forecast function provided by the TimesFM library. We need to provide it with our input data, the frequency, which we'll set to daily, sales as our value column name, and -1 for the forecast job. The function requires the identifier for our time series to be a unique ID, so let's revise our data frame to include that. It also requires a datetime column, so let's rename our date column to match. With that done, it looks like we've successfully created our forecast. Monitoring our GPU usage, we see it's still relatively high at about 12 gigabytes out of the available 16 gigabytes, indicating the model is utilizing the GPU effectively. Our forecast data frame looks as expected, projecting out 96 days from today. This is about 3 months until August, which aligns with our specified horizon. The model output includes various quantiles, and the forecast continues the linear trend observed in our original data. Notably, our forecast was pretty quick, taking only about 11 seconds of wall time. As always, we'll provide the sample data file and the Jupyter notebook in the video description so you can follow along and experiment further. Thank you very much for watching, and please enjoy responsibly.